All right, good morning and welcome back. So today we're going to talk about 5.6. Now, some good news for us, even though we are now fully remote, if you have that packet, you have our notes all the way till December 4th, I believe. So that'll get us for a while. We'll continue to do those. I will have videos posted after the class times, but please, once again, remember it's important that you try to come to the class if you are able. Okay, I know you're gonna have things that cause conflicts, but try to sign in. I'll be taking attendance. You guys know as well as I know, when you can ask questions and get instant response, that's going to be a better workspace than just watching a YouTube video. Okay, so try to be there as much as you can. Please try to come to those. So as far as the notes then for the remainder of the semester, I'm going to try to figure out a plan so I can have packets ready for you to pick up if you want one, or you guys can at least print it off on your own. We'll definitely have that option. So as always, please reach out if you have any questions. Things are changing. I have office hours each day from 2:45 to 3:30, or Monday through Thursday, I guess. And then on Friday, I'll have some office hours in the morning. I'll talk more about that. If you need me, please reach out. And please don't give up or take the lazy route. Last spring was different. We were still trying to figure things out, so there was a lot of freedom. And if you didn't do anything, your grade pretty much stayed the same. That's not going to be the case this year, okay? We are prepared for this. You guys know how to use the software. You guys know how to use Google Meet, how to use It's Learning, how to use Delta Math. And we need to keep learning. We need to keep progressing. We need to keep getting better and prepared for next semester. So let's go ahead and get started. If we look here at these first few, these are kind of a review from last week, and it says, how do I evaluate these logs? So once again, we talked about this last week, but we can begin by, if we rewrite it using our memory trick. So just in case you forgot, base stays base. And then the other two switcheroo. And then we can use this to change it into exponential format. So if we look here, log of 5, 625, log base 5 of 625 equals box. We don't know. Remember, 5 raised to that box equals 625. Okay, and if we figured that out, 5 to the 4th would give us 625. Okay, so once again, I don't know what that equals, but if I rewrite it, 3 raised to what power gives me 1 over 27. Since it's a fraction, we know it's going to be negative. And our answer will be negative 3, because 3 to the third is 27, so it'll be 3 to the negative third. Okay. Now our next one, 2 to what power gives us 32, so 2 to the box equals 32. Remember that box means what, or it could be a question mark, it could be an X, whatever you want to put there. So 2 to the 5th power, okay, gives us 32. And then finally on this one, 49 to what power gives us 7. So it's going down, so we know it has to be something that is less than 1. And in our case, the square root of 49 is 7. So the square root, we write that as 1/2. Okay, so that was a bad circle there at the end. Whoops. Here we go. So 1/2. Okay. Now, that's all well and good. Hopefully that's familiar to you. However, as we get here to the next example, what if we can't figure out what the answer is? So 2 to the box, so 2 raised to that box equals 7. Hopefully you guys already know 2 to the second is 4. So that's too small. Okay, we also could try 2 to the third, but that's 8. So that's too big. So it has to be somewhere between 2 and 3. And we can guess and check all day, but that's going to be a lot of work. Okay, so instead, we are going to use our graphing calculator to help us out. Okay, we can get a much more precise answer. So in our calculator, we're going to use something called the change in base formula, or the change of base formula. So this change of base formula, up here, say we have log base b of x. We can figure out what that is by putting the log of x. Here there's no base, which means it's base 10. Okay, we change it to base 10. That way we can type it in our calculator. And we'll do that divided by the log of that base, or b. Remember here, the base is on the bottom. So base bottom. So that b came right there. The base is on the bottom. And if we do that, so in our case here, from example 1, we can do log of 7 divided by log of 2, and we will get something. So right here, the calculator, remember, hopefully all of you have this. If not, please send me an email and I can help you download it onto your computer. I can walk through that with you. The other option is you can use Calculator. Once again, it'll work exactly the same. Or there's another app, I believe it's, it's based off TA84, choose 84 or something, Calculator 84. So send me an email if you need help getting an app on your phone. I can figure that out. So if we look here, log 7, so we're going to do log button over here of 7, then close your parenthesis. If you're using the Calculator app, instead of closing the parenthesis, you'll have to hit the arrow to get out of it. Okay. Then divided by the log of 2, and then I close my parenthesis and I hit enter, and that's my answer. And we're going to get in the habit of going to the third decimal place. So we're going to round that. So it'll be 2.807, and that is our answer. Now, just to kind of show you guys how this works, if you want, like up here in example C, we knew that one, but say we didn't, or you just didn't want to think about it. We've been kind of doing this a harder way. I've made you guys think it through. Now we know the shortcut. We can use change of base, so log 32, close that parenthesis, divided by, and we'll do log of 2. Remember, base is on the bottom, so that'll be what it is, and we get 5 there, which was our answer here. So you can see it works. Let's go ahead and do this again. Same concepts here. So if it helps you to rewrite it, you can rewrite it. But anytime we have both the base and right here, this term exists, when both of those are numbers, we can simply calculate it. So in our calculator here, we're going to do log of 3 over the log, remember base is bottom, so log 12. And if we do this, we'll get log of 3 divided by the log of 12. And we get here, we'll get 0.442. Okay, so that one is less than 0. This will occur when we have a smaller number on top, so 3 over 12, where here it was 7 over 2. Because we know what it's saying is how 12 raised to what power goes down to 3. Okay? If we would rewrite that, we're saying 12 to some power equals 3, and the only way that can happen is if this is less than 1. Okay, so our next one, log base 5 of 600. So we're going to do the 600 on top divided by log of 5. What will we get? So we'll do log 600 divided by, once again over here, log of 5, and we get 3.97. Now it is a 4, but it's 4/6, so we're going to round that up. So 3.975. And real quick, in case you don't feel confident on these, if we want, we can also check our answer, okay, by plugging that in to the calculator. So what I mean by that is, here, give me 1 second. So plugging it into the calculator. Okay, we know this was equal to some box, so 5 to what power equals 600? Well, now we know what the power is. It's 3.975. So I'm going to go ahead and do 5 raised to the 3.975, and we'll see what that equals. So we'll do 5. Then you can use this caret key up here right above the divide sign. So raised to the, and in our case it's 3.975. I hit enter, and now look here, we get 600.351. So if we round that, it'd be 600.352. Now, some of you might be saying that is not exactly 600, which you are correct. The reason it's not exactly 600 is because over here, when we found it, we rounded it off to 3.975. It kept going. So if we wanted the exact answer, we would need to keep going. But in our case, it is 600. That is very, very close. Okay, and it's because we rounded that it's slightly off. All right, so once again, we've got one more to do. And that check is optional if you just want to make sure. So this last one, once again, we'll do log of 52 divided by, log 3. Base is always on the bottom. So log 52 divided by log 3. And we hit enter. And we're good to go. We got 3.597 if we round. Okay, so once again, if you want to check that, we could do 3 raised to the 3.597. We hit enter, and 52.0241. So once again, it's a little off 52, but very, very close. And that, once again, is rounding error that causes it to be a little bit off. Okay, so now that's the one thing we're going to talk about today. The second thing is, what do we do if we need to expand a log? Okay, so expanding logs, this can be a little confusing and maybe doesn't seem so applicable to the real world, but I'm going to go through quick and teach us some rules. So the product property tells us if two things are multiplied inside the log, we can rewrite this as if they were added together. The two logs were added together. So in our case here, we have a 5 and an x. They're multiplied. So they're both still going to be base 3. So it'll be log base 3 of 5 plus log base 3 of x. And that would equal the same thing as log base 3 of 5x. Now your quotient property is similar, except instead of adding them, you would subtract. So right here, there's still going to be log base 2. So log base 2 of x, and then we're going to subtract log base 2 of y. And our final one, when we have an exponent in there, the exponent actually comes out front. So we can rewrite log of x to the 5th as 5 times log of x. Now remember, this one does not have a base written, which hopefully you guys remember means if there's no base written, we know it's base 10. So when we are expanding, we can use all of these rules at the same time. So we got a few examples here. And example 5, the first thing I want us to do is establish how many different logs are going to have to write. So if we look here, there's the 3 and then there's the x to the 5th. So we know we're going to have 2 logs. And all of these logs are going to have a base of 2 because they're right there. So I can start off log base 2 of 3. And then remember we said it's going to be plus. Now combining the power property with the product property, the power property tells us that 5 can come out front. So 5 times log base 2 of x. Okay, our next one, example 6. Once again, we're going to have 2 logs. There's one on top, one on the bottom. So I recommend you always kind of jot that down to keep it organized. Now this one does not have a base, which means it's base 10, but we don't need to write it, okay? So let's start with the top. So that 2 will come out front for the power property. So 2 times the log of x. Now instead of a plus, we're going to have a minus because we're using the quotient property. Now we're dividing. And it will be log of 7. And both of these do not need a base because they both have the base of 10, just like the original. Okay, so now example 7. Let's see, we've got 1, 2, 3, 4 different parts to it. So we're going to have 4 logs as our answer. So log base 3 for all of them. We'll start out with the first one. Let me erase this so you can see it. But we'll know it's the 2 here. Oops. My computer's being a little difficult. Sorry about that. Okay, so it's the 2. So log base 3 of 2. Then plus, we'll use that y to the 4th. So 4 log base 3 of y. Now these are on the bottom, so we have to subtract the log base 3 of 5. Now I know some of you are thinking 5 times x, but x is also dividing, so we have to subtract again and do log base 3 of x because we're subtracting it to show that we're dividing that whole thing. Okay, and that would be our answer if we were asked to expand it. Okay, now example 8, same approach. This one's ln, which we know means it's the natural, or that's the equivalent to log base e. Okay, it's also known as our natural log. We can keep writing it with ln, so you can either do ln lowercase l, or I like to write the uppercase L just so it's a little more obvious. Once again, we've got 1, 2, 3, 4 different parts, so 4 different logs for our answer. So we'll start up top again. So ln of 12 plus ln of x minus, we're moving to the bottom. Now the 7 will come out front. ln of y. Once again, minus, put the exponent at the front, 4 ln of z. And that right there is our answer. Now our final one, okay, final part of today's lesson. We've got the x to the 3rd out front, the 2 on the bottom, and this y in the square root. Remember, square root, that could be written also as y to the 1/2 as an exponent. So don't forget, if you have a square root, that's the same as an exponent. So you got to bring that up front using your power property. So let's start with, it's going to be 3 log base 4 of x. Okay, plus, we got to bring that 1/2 out. So 1/2 log base 4 of y. And then the 2 is on the bottom, so minus log base 4 of 2. All right. So that gives us our final answer. Now, just so you guys are aware, today there is a brief It's Learning assignment. Kind of my expectation is that you should try to have that done before your next class period. Okay, so that'd be either Wednesday or Thursday. If we have people that aren't participating, I'm going to have to start calling home, figuring out what's going on. We got to stay involved. We got to keep working, okay? Don't give up. I know Thanksgiving's close. I know we're near the end of the semester, but you got to finish strong, okay? Don't give up 18 weeks of hard work just because you're at home now and it's easier to play PlayStation, okay? So keep working hard for me. If you have any questions, please reach out. Also, just so you guys know, this 5.6B review, if you want to do it for extra practice, you can. It's not for a grade. Originally, we were going to work on it in class. Just give me some time, but since we're only meeting now every other day, that's not going to happen. But I will upload those answers, and you can see how you did. It'll be in the folder for 11/16. So hope you guys have a great day, and please let me know if you need any help.